Okay, yeah, so hi everyone, nice to see you here. I know some of you are already familiar with the bioimage model zoo, and for you that might get a bit repetitive, but still, maybe we'll get to show some new things. And the idea for Wei and me to do it together was that I will first show the things from like really a user perspective and very high level, and then he will tell you about some of the technical details of how the zoo is actually working behind the scenes. Yeah, so I want to talk a bit about the ecosystem, but mostly about the bioimage model zoo. And the other parts of the ecosystem will be presented at these other webinars that Bea has also already described. Right, so before we get like into the zoo itself, let me just maybe quickly give you some motivation for how we got there. Right, so if you think about feature-based learning, right, which is a question that is very close to my heart because we are also the group that is developing Elastic, right? Then the way that works is that, well, you have your data, right? Then you think for yourself for the moment, right? So what could be the interesting data transformations that would be important to achieve, say, a segmentation in the end or some other task, right? Then, so you have those fixed, but then you add a little bit of training data into the black box of a machine learning classifier. And out of this, you actually get a segmentation, right? And the way that works is that, well, you start from your data, right? And then this data is already projected into some kind of a feature space because you thought of this. And you have to remember that, of course, in the absolutely ideal world of fluorescence microscopy, you would now have like your foreground pixels clustered somewhere completely separate. But this doesn't happen in practice. And so in practice, we actually need labels to decide where to draw a decision boundary. And this is why we ask people for training labels. Right? So then you could give brushstroke labels, or you can also do dense labels if you want. And then we project that into the feature space. And then we can actually get the, decide where we draw the decision boundary. And then out of this, predict for all the pixels and actually get your segmentation. Right? So if you wanted a simple problem solved, this would be pretty much all you need to do. Now, if you want to, if you try that and you see that, well, yes, maybe you're not as good as you thought in deciding what features are actually important for your segmentation problem, right? Or if you just have a difficult problem in there, then we can go into deep learning, right? The deep learning will be the subject of what we will talk about today. And the main difference there is that your black box is getting much bigger, right? Because now it has to learn not just where you draw the decision boundary, but also how do you transform your data so that it actually is separable in the end. And to do that, because it has to learn much more, it also needs a lot more training data. Right? And in case of segmentation algorithms, which is the main problem that my group wants to solve, you also need to provide this training data very densely, right? So you have to really give it like fully annotated images with labels. And this is a lot of work, but it's kind of worth it, right? So we think that, yeah, deep learning is definitely the way to go. It works. The great thing about it for me as a method developer is that you can train the same black box, right? So basically, well, in the reality of bioimage analysis, you could say you can train the same unit to do many different things. And that also only depends on the training data. And training data is something that biologists can provide, right? So we have also like this nice separation of tasks of what the method developers do and what biologists do. And then once it's actually trained, it becomes deterministic and it's fairly easy to run. Well, the limitations are that, yes, you need a lot of training data. Also, training has to be done on a GPU, which actually requires quite a lot of computational resources. The more training data you manage to come up with, the more computational resources you need to train on it. Also, if you're trying to solve a problem that has not been solved before, it also requires quite some skill. Like, if you suddenly decided that nuclear segmentation needs more ideas, right? So this is something where there is a big established baseline and you would have to build on top of that. That is hard, right? Because people have already gotten quite far. At the same time, if you want to find a new organelle that people have not actually trained to find before, and you need specific laws, you need a specific way to handle the imbalance in the data, all of this is also requires some thinking, right? So it works really well, but there are these limitations on the amount of training data and on knowing what you're doing when you're training, right? And that's why, we thought that it would actually be great if pre-trained models that us as model developers, we create, could end up in the end user software where people could run them without code. right? So we all train models, right? So all the image analysis facilities now train models. And it would be great if we could just exchange models and then run them in our tools and not have to every time look deeply into the code of the model just to see what axis order it assumes for its input or other things like that, right? And then that, of course, raises the question of like, what software will you want to run in? Because there are many different softwares for bioimage analysis, right? So this is a screenshot from the Image Odyssey forum from October, I think. There are probably more by now. Not all of this represent tools that could be running deep learning models, but many of these things are. And yeah, so what we were thinking about there is like, how can we, as method developers, then enable all of these tools to share networks between themselves? And that was the goal with which we have set out to create the model zoo years ago, together with Wei, is to then indeed have models that are fully reusable, right? So in a way where I could share a model and Wei could share a model and Florian could share a model, and then we go into different consumer software and just run this model as is, never looking into the code, never adjusting to data, never thinking of like, okay, oh, there we had that many channels, so now we have to introduce a dummy channel, or like, yes, and here we have to readjust the tiling, and here we have to readjust something else. So never look into the code of the model itself, just take a model by name and apply it. That was where we wanted to get. And here you can see an example of a popular studies model from the zoo. And you can run directly in DeepImageJ if you like Fiji, or you can run in QPath if you like QPath. You can also run it in other tools. You can also programmatically use it in Notebook, in the notebook where it was trained, in this case in zero cost. You can also run it with the studies Python library. And this is still the same model, and you still don't have to look deeply inside for this. So what is a pre-trained model? What is that? What are these things that we are sharing? The model itself is, well, the architecture, right? And then the weights inside the layers that the training has converged to, right? So this is like the precious thing that actually makes your model work. But beyond that, if you only share these two things, you still have to look into the code of the model to be able to give it images and take the output images and then display them the correct way. And so then on top of that, we actually defined our standard for the metadata of the models that are, well, somewhat specific, you could say, for bioimages. It's not very specific, but it's tailored to, because we want to solve these problems for the biological images. And there we have fields like input shape or output shape, or input normalization, pre-processing, post-processing, some other things. So some of these fields are obligatory, like authors, right? Or how to cite a model, or what is your expected input shape. Some are actually optional, right? You don't have to have post-processing. You also don't have to have pre-processing. So in the end, there is like this bunch of fields that you have to fill out, but we have very convenient tools that help you to do this. And then you can, starting from a model where you have the architecture and the layer weights, you can pretty quickly come to a model that is actually shareable with other people in a standardized way. And then all of this then goes to this website, bioimage.io. And in here, you can see this is a listing of the community partners. I'm not sure if this image is completely up to date. There are probably more partners now. We have a little carousel. But all these partners can actually run models that follow the specification that we have defined. Okay, and then the models in there are actually quite a few, and we will go to the website and look at them later on. So there are things for very different tasks, right? We have models for segmentation, probably more are for segmentation than for other things, but this is also just an imbalance. So if you have models that are not for segmentation, we are also very happy to take them. There are some classification models from Wei, actually. There are quite a few image restoration models from Florian, but also from completely external contributors. There are also many others, right? So people have contributed models for all kinds of things in there. And then, as we were building the zoo, we realized that actually we need to approach it in a more systematic manner than just having one single open source project. And that is how the AI4Life consortium was established, to build the zoo and everything that has to come around it. And the overall goal that we have set to ourselves was to, bridge the gap between the computer science community that is developing the models and the life science community that actually wants to use them. And for that, we want to develop then the standards for the models and also standards for the training data sets. We want to wrap the methods in a way that would allow running them from tools that life science community actually uses. And then from the life science community side, as you will hear in, I think, our very last webinar, we wanted to have, let's say, a list of problems that people feel need to be solved to really move their community forward. Right, so AI4Life Consortium actually has 10 partners, right, all across Europe, across 8 countries, runs for 36 months, running out end of this year. Originally funded with 4 million euros. And like Bea said, Florian and me are the scientific coordinators. And Wave actually develops the website. So yeah, all of these people are happy to show the AI4Life community for you. Right, so all the development is actually happening in the open on GitHub. Right, so there is the Bioimage.io organization, and here you can see, I think these are not all the sub-repos that we have, right? But there is the repo for the model zoo itself, Bioimage.io. This is the spec Bioimage.io is the library for the specification of the models, right? So basically for this metadata file. And then we have 2 libraries that actually allow to run models that follow the specification, the core Bioimage.io Python that runs it in Python, and the JDLL which runs it in Java, so that it could also be used by tools like DeepImageJ. Yeah, and then there's also the other repos that come in touch with those, but these are the main ones. So if you want to contribute, if you actually feel like joining this wonderful community project, we are always very happy to hear from you in the issues, in the pull requests, also on the forum. So the zoo itself presents the models in the so-called model cards, and we also look at them now. Right? And the model card actually parses the specification, right, that you have provided with the model, and then outputs it in a nice readable way that allows people to like look at the models and see how they can be used. Yeah, so with the whole thing, as I'm sure you already realized, we want to go towards a reproducible ecosystem, right, where we would have the models that you can really rerun and get the same results as you had in the published paper, right? And here you can see how we are introducing the HPA cell image segmentation data challenge, right? And then here you have like the winning model that you can just run in the Python code, run all the 3, and then get them to be displayed in the different viewer tools. It also has a chatbot that by now has been published that can help you in your image analysis tasks. It also knows the Model Zoo model cards and the docs, so it can also help you find your way through the Model Zoo. What about the data? So I will not go deep into that because we will have, Teresa will give the next, and Matthew will give the next webinar. We'll talk a lot about this, so that's just like a teaser. We know that the annotations are critical, well, for reproducibility, but also just for training more models. And it's interesting to think about how can we make annotations more shareable, right? Because there are multiple formats, there are multiple ways to how do you define, for example, a segmentation, right? And there is now this white paper about this called MIFA. And so if you want to share your annotated data, which I strongly applaud, that's the place where you could check how this is done. Right, and within AI4Life, Bioimage Archive now has a whole AI gallery where you have, on the one hand, AI-ready data sets that can easily be consumed by the models you want to train, but then also a model evaluation platform that takes models from the zoo and applies them to the AI-ready data sets and then ranks them by their performance. Yeah, so for training and fine-tuning, so what I talked about before is like you can just download a model. What can you do if you want to slightly fine-tune it on your data? Right, so they are actually, many of the models are linked with the notebooks that were originally used for training or with their source code. And there, what people can do is go to Colab and then use the notebooks from BioPy or from ZeroCost-DL and change the labels change the input data and the labels in the training routine, rerun that to the fine-tuning. If you don't like Colab, you can also use the DL from Make Everywhere, which has been developed in Ricardo Enriquez lab, also as part of AI4Life. Where you can, run validated Docker containers and have the full control without actually using the Google computational resources. Okay, so now maybe let me try to share the other screen quickly. Wasn't there like, okay, if I press share again, let's see what happens now. Because sometimes, yes, okay, that's the Zoom. I hope you see the other screen now. Speak up if you don't.
It's good.
Yeah, that's what the model zoo looks like. And here, they have the community partners, right? And you can, see a few more that I didn't show. They're all there. We love them all. And here you actually have the model cards as they look now. We will have an update to the website happening, well, within the coming months. But for now, this is what it looks like. And you can also see that every model in the zoo, just because it's easier to remember an animal than a DOI assigned by a Zenodo-like thing, right? Every model actually has an animal name, like this one here is called discrete rooster. So the names are randomly assigned. But this is how we, between ourselves, actually reference these models. And then here you can see an example of a model card, right? So this model has a DOI assigned by Zenodo. It has been downloaded many times, great model, right? It can run in multiple tools. And then, yeah, so here you can see this is the instance segmentation result then. Contributed by Ignacio, wonderful. And then the functionality that I wanted to show you maybe very quickly is how you can test the model on the website yourself. Right, so here, this is done through image.js, and I think Wei will actually mention how this works under the hood. But for example, you can load the sample image, that is the one that you can see in the model card, and now run the model on it, right? And you see it does the tiling by itself automatically, right? And now you can have your segmentation result, right? You can also use this little Fiji window to open your own data, including loading it up from the from your local machine, right? Please don't make it too big. But generally, you can try any of these models, not most of these models, on your data and immediately see how this will work, if it works. Yeah, so beyond the models, we also have like some links to the data sets that are often used for training or have been used for training of this, right? And then the applications, which mostly include the notebooks. Okay, and then with that, let me try to go back to the slides quickly. Because where did they go? What is it doing? Yes, I want to share the PowerPoint. Yes, come on. Let me try starting and stopping again. Right? Maybe this will look better.
This is the presenter mode, so
yeah.
still not
better.
Not yet.
Oh, I'm sorry. It's like for some reason, sometimes it just doesn't do it. Huh? Okay, let me find the non-presenter mode, and now we go here and we say share again, and we say no, this one, PowerPoint. Yes, this one.
It's still presenter.
Still presenter mode.
Yeah.
And like that?
Good.
Yay. Okay, then the next thing I wanted to, or maybe the last one that I wanted to show to you is our idea of how you could also, like, for example, boost data annotation with that. Because, sometimes you take a model and it has been trained for a similar task. It seems like it's working pretty well, but you still want to go like the extra mile before you declare that it's really fully working now. Right? And then you could, once you can declare that it's fully working, then you can also reuse the data for training a model that is really fine-tuned on your data. And so the idea here is that you can download the pre-trained model, and then here using the Elastic example, because Elastic is our software and I like showing it. But here we wanted to show how you can speed up the data annotation. You take the you run this network in Elastic, you get some boundary predictions, you actually proofread them, or like you quickly improve them, right? Then you curate the results. Now you have the new training data. You use the notebook that came with the model for fine tuning, and now you can use that on your data in other software or in Elastic again. But supposing you wanted to run, say, Morpholib.j on it, you can now go to Fiji with a new model and analyze it there. Okay, so the way it looks in Elastic is like that. Right, so you start from, so this is a workflow that I had in mind for this. So this is the segmenting from the membrane information. Right, and then you predict boundaries, you correct a few boundaries. So there's green and red labels here, and then you actually get your complete objects. Right, and now if I wanted to try it out, right, so don't click on the data link. That's a leftover from a very interactive webinar we had before. But if you look at these two data sets that I actually wanted to use, and now open the Bioimage.io website in your own browser, can you type in the chat what you would, which model should I try loading there? And I will, meanwhile, share the Elastic window with you. No, that's too early. Okay. So do you see the data? So, okay, let me quickly stop this. And while you're looking at the zoo, I hope, you could try to find me a model that I could be using here. And I can share the Elastic window with you soon so that you see the data again. Oh, someone has an idea. Classical edge detection. Well, it is, but I need a model that I could run. Let me share this window with you now so that you still have a view on the data. So, and how do I see the chat again? Why is it gone? No, it's not gone. Okay. More versions in the zoo. Pioneering Rhino or Thoughtful Turtle. Pioneering Rhino is a pretty good model. Thank you, Melody. So now let's actually try it out, right? So there is another one that also works, but I can just copy paste from the chat directly into the little window here and say Pioneering Rhino. Well, you would think, but I think the Zoom disables it. Pioneering Rhino. Let's see if I spelled it right. And I see, yeah, so it can find the model by name and download it from the zoo, and then you can actually apply it. And then you have a prediction, right? And now this is actually not too bad as a prediction. And now you can export this prediction from Elastic. And then open a new workflow, right? We can say, yeah, I can save that or even not save that. Okay, we can close this one. Yes. And now we can open the other one that was reliant on it, that could rely on this. And we take the same image as before. So that would be what, 78. Right, and now we load the probabilities that we just computed. Right, and you see this was our model output. Right, and now we do the steps that we do in this boundary classification workflow or in this boundary-based segmentation workflow. Right, we basically compute the watershed, and then the important point is that you go here, and here you label the boundaries that are wrong, and also some of the boundaries that are right. So, like for example, this one, or this one. These are all the correct boundaries of like the real boundaries of the cells. Or here. Right, and then let's see if that actually gets yeah, that's getting close. And now you can take out the intermediate ones. And I would say the red ones are now the correct boundaries and the green ones are now the incorrect ones. So now we can actually compute the objects defined by these boundaries and look at them. And here we go. Right, and now you could also still label some more and say, okay, this is actually not a real boundary. And now this is a complete object. So now from segmentation done by a model that was trained on a different data set to also predict boundaries, but in a slightly different setting, you can see that the prediction is not ideal, but with a few clicks, you can actually correct it to be pretty good. And with that, now armed by this, you could actually go and train a new model. If you look in the notebook that was used to train this one, and afterwards upload this new model so that other people could use it. Okay, let me for the last time, try to go back to the slides. And now I just have the Outlook slide before I transfer over to Wei. So the community on the method development side is actually coming together to share the pre-trained models. So I also hope that for us as method developers, there will be a lot of cool, interesting fine-tuning and domain adaptation problems coming up that we will only now be able to develop because we will have a large variety of pre-trained models, and we would try to make all of them contribute to making each problem more solvable. I'm also hoping to see a big rise in the use of deep learning by non-experts enabled by these pre-trained models that we are sharing and by the tools to run them. And of course, DL models are not without their drawbacks. So we should also ourselves be ready for an open conversation about how this can be limiting and how can you properly validate, how can you avoid hallucinations, all of these things. And yeah, to finish, I just wanted to encourage you to share your data, especially the annotated data, because that is what allows us to train the models that we can afterwards share. Okay, now Wei, over to you.
All right. Thanks, Anna, for the thorough introduction. For my part, I'm gonna mostly talk about the underlying infrastructure, and then I'm gonna give a bit outlook to the project as a whole. So just to reiterate, what we are trying to do with the AI4Life and the bioimage model zoo, trying to provide fair models and trying to democratizing AI for bioimage analysis. We want to build a community, enable collaboration, explore the future of bioimage analysis. So this kind of a few goals we want to achieve with this model zoo. One of the most basic feature we try to do is that to make the model sharing easier for different users. And then I will, the one of the most important thing when we build the infrastructure is this storage. How can we host the models, for example? I already mentioned that we have this bioimage IO model spec, and this is the first thing we try to do. To enable sharing, we need a kind of standard. So we created the standard in order to enable cross-compatible tools. And then in the early versions of the bioimage model zoo, we actually post these models directly to Zenodo. Later on, we had to switch because of some stabilities to issues. So this is like what we are doing right now. The models are actually hosted on an S3 bucket hosted at Ember EBI. So what happens is that when user upload the model goes to our S3 bucket, and then this bucket, they are open to everyone to download. So you can also download from the website. But in the meantime, our server side are gonna publish this model to Zenodo as well, to such that you can get a DOI and also have a kind of backup for the models. The other part we want to enable is this easy model inference. As Anna was just demonstrating, we want to let the users to try the models without actually downloading the model. Imagine you just have some images. You are not sure which models you can use, right? So what we actually trying to make it easy for you is that you open the website, you go to the models, then you can try with your own images. And this works by building this entire compute infrastructure for running models in the cloud. And this is not an easy task because there's a lot of challenges when we actually trying to set up the, we have a few attempts in the past, but it's really tricky to handle so many models. Like we're talking about, initially we have like 40 something models, and then the number gonna increase, tremendously once the website is you know, widely kind of shared with among the community. And we are also serving many users, and most importantly, we only have very limited GPUs, right? So this is a very challenging task. And on the other hand, that if they think about it, if the user goes to the website, they are requesting different models. So when you have limited GPUs, you are actually need to wait for a long time because the server needs to load different models, right? Let's say you only have, in the extreme case, you only have one GPU on the server side, right? And then one user comes, they load model A, and the other user comes, and then they just, you need to switch to another model. So this model, they are quite big, and the overhead of loading is actually take a lot of time. Plus this kind of inference time. And especially, you know, the users are quite not so patient. If this is gonna be very bad, if you kind of had to, you know, you drag an image and you wait for a minute to get an image, which is a bad situation to have. So our solution has been adopting this existing solution from NVIDIA called the Triton Inference Server. It's basically a container solution. You just run a container, but what it does is that it allows you to, sitting on very limited GPUs, like 1 or 2 GPUs could also work. And then you can load a repository of models. And what Triton Inference Server does is I can schedule the tasks. So it manages the GPU memories efficiently such that we can serve many models at the same time for many users. Of course, there's no magic, right? But this is kind of, if you have so many users, then you will have to wait for a while. But this server just make our life much easier to serve many users with many models. It just does it automatically. And based on this, we built this Bell engine, which is a kind of a server infrastructure for support the inference with all the models from the model zoo. We extended that by adding this Python library Haifa to allow connection from the browser. For example, what you see already, the test run is through the browser. But our aim is trying to provide it as really an engine for bioimage analysis where you can connect with different clients. For example, Elastic, Napari, different tools could potentially talk to the server and send an HTTP request, for example, and then the user will, you don't need to set up the, you know, infrastructure, especially good for evaluation purposes, for example. And this is the, which you already see this demo, right? It can run in browser. So with this kind of setup, you can have a large variety of options, and we already work with the community during different hackathons organized through the AI4Life project. And then it's already support a lot of different clients where you can, you know, talk to the bioengine. The most, I think, beneficial thing by doing this is that it can really simplify the setup for the user, because you don't need to install those heavy dependencies for running deep learning. It's just much faster. Of course, it's not a very scalable solution. That's why we're looking to how can we support you to deploy your own bioengine in your HPC, for example. And we currently, we have some initial version released, but the goal is to allow on-prem deployment of bioengine. So we are working with a few partners like, you know, Human Technopole, for example. We are deploying this Kubernetes version of the bioengine at Human Technopole. It enables better confidentiality and more sustainable, because we cannot provide that compute from the AI4Life project. But and also is kind of is a more sustainable solution to be able to let the user deploy their own version. So in the meantime, we're working on desktop version where you can run it on your own desktop. But of course, this will be limited because you often have limited GPUs. The other part is the public cloud. We have been testing different ones. For example, Google Cloud is the one we are using to serve the bioimage model zoo website. But we are also looking into deploy, working with different partners, for example, EOSC and EOSC for Life and sorry, the EOSC, for example, EOSC Life, and for example, they have this Kubernetes cluster. We are working with the portal, so you can easily launch a kind of bio engine through their portal, for example. There will be more a dedicated introduction in the upcoming webinar, just as a kind of teaser. Is June 12th, and you can see more details, information about this. And yeah, I think that's it for the bioengine part. I would also like to talk about the future of bioimage analysis and see how we as an AI4Life, as a kind of consortium, gonna support this kind of mostly, you know, the bioimage analysis through the web and through the cloud, and also through this kind of you know, language model, ChatGPT, a lot of things. So before that, I will just do a kind of very fresh demo, some kind of work we have done before recently, just to give you a feeling on what kind of times we're entering right now. I'm gonna show you this work in progress chat interface where you can talk to it. So what I have here is that there's a very basic chat but in addition to this, you know, just we connect to OpenAI API. In addition to that, what I have here is that I embedded a code interpreter. So basically, you can run Python code within this chat, right? So, and also here I have this voice interface enabled. So I'm gonna show you that what we can do with it. This is a very, very early version, but I just hope you can get a feeling on how it works. Hello?
Hi there. How can I assist you today?
Could you print hello world?
Sure. Here it is. Hello, world.
No, I mean through the coding tool.
Got it. I'll run the code to print hello, world. The code has been run and it printed hello, world.
Yes, could you just show me a 3D scatter plot with Plotly?
Sure. I can create a 3D scatter plot using Plotly. I'll generate some random data for this plot. I've created a 3D scatter plot with random data using Plotly. You should be able
Okay. So let's try some image analysis. You have this scikit image in this tool. I would like to for you to load some images and then we analyze them. Could you show me a just random image from the scikit image?
Yes, I can load and display a random image from the scikit image dataset. Let's take a look at one. I've displayed a random image from the scikit image dataset. It's an image of a cat.
Actually, I want to work with some biological images. Do you have that?
It seems that the required libraries for displaying biological images aren't available. Is there anything else you'd like to try or discuss?
Try this. Sorry. Could you see the new one I sent you? Sorry.
Is there anything else you'd like to do?
Just hold on. Well, actually, you can download it. Just use the scikit image to read this URL. Could you load it through this NumPy? Download it and then load it through NumPy. But I need. So it's struggling with the. Let's try this cameraman image. Okay, so could you run some segmentation algorithm? Okay, and then could you segment the image? Could you count how many pixels? Okay, so I think this is a very just I'm gonna close it. I was hoping that we could load the other image. But I hope you can see that this is not ready for loading the image I sent to it. But I hope you can see that through this kind of multi-round of interaction, it can do a lot of things. And so this is a kind of a more recent version of it, but we also have this bioimage.io chatbot, which based on the same technology, right? So that here the most important thing is that we try to have this, this is another demo where we can mount the images locally. You can provide the images and then you can ask it to say segment images. What we actually does is that we actually mount all this community software documentation, so it will have a better understanding on how to use these different tools. So in this demo, it's a very similar demo, but it's more tailored for biological image analysis. In this demo, we actually talk to the bio engine, right? So as you can see that it can generate code to talk to the bio engine to run some analysis through our cloud infrastructure. It can also recover from errors, what I'm showing you. It's a similar demo as this live demo with this live version, because it's gonna be much more powerful if we can actually connect to this bio engine, be able to run all these models from the model zoo, for example. And I also showed you this in this demo is doing some kind of visual inspection, right? So in the future, this model, this kind of tools, they can also not only write code to run the analysis, but they can also see the output and then do a kind of visual inspections on the result, and then they can go back into refine the code to do things. So it's really exciting times to come, and this is you can try it with this get a feeling of this by image chat through this link, and you can use it by logging register an account. And then the one I showed you is still work in progress, but we hope we're gonna connect it soon. And this is the underlying how it works. If you're interested, feel free to read our paper. And so the other thing I want to briefly mention is not just how we can enable collaboration. So right now we work with desktop tools, which has a lot of limitation. One of the significant hurdle is through when you do collaboration, right? You need to send files around. And with our solution, with bio engine, and connection with the model zoo, and because it's cloud-based, and it's much easier to do this kind of streamlined collaboration. And more importantly, it allows you to talk to a chatbot, for example, just like what we did, right? So it's not just human to humans, but also humans to AI. And then this will enable much easier collaborative analysis. I'll just show you one example that this is an ongoing work in within the AI4Life community. The partners has come together that we work on this human-in-the-loop collaboration image annotation tool. The major, the core part is this, bioengine. Here we also load the microsam is segment anything model from Konstantin Papa, who work on this, trained microscopy specific segment anything model. So we work with him, his group, and load the model in this bioengine, and such that we can, and then we provide this kind of user interface where user can mount their own images to our server. And then the other side is that the annotator. So it's essentially a service for everyone to load their images and then share with their colleagues, with your colleagues, with anyone who want to contribute to annotation, right? So essentially it has data provider which provide this data, start a session, then you're gonna get an URL, and then you have an annotator who's gonna receive the image. It's gonna they can, during the annotation, you can interact with the microsam model running in the bioengine. This is kind of enabling this interactive experience. So there's a demo already. You can try it, and I will not show for the sake of time. Yeah, feel free to give it a try how it works for you. So just a conclusion slide. So what we are aiming for with all these things putting together is a platform for AI-powered bioimage analysis. So we have AI models, analysis tools, data repository, knowledge base. And then, we want to connect them through the bioengine, and then enable collaborations, connect to chatbot. Hopefully, we will also connect hardware to the platform to enable collaborative data acquisition and analysis. Yeah, I think that's it. Thanks a lot for the, it's a great community, AI4Life, and then also for the funding agencies. Thank you for your attention.